Howdy, boys and girls. This is Mrs. Dunn,
And this is Miss Sarles.
and today we're going to be talking about combining like terms. So when we have like terms, we need to have something that looks a little bit like this. So we have 12x plus 15 minus 3x, and we call this an expression. It is not an equation, and we've talked about the differences between those, but Miss Sarles, will you help me review what's the difference between an expression and an equation?
An expression is just a combination of variables. Could have variable, doesn't have to, and it has to have some sort of an integer, and then one or two operations. This one has two.
Okay, and how is that different than an equation? Why is this not an equation?
An equation has to have an equal sign and then another expression. It would be two equivalent expressions.
Okay, so that was a good review. I have a whole bunch of arrows here, so what we're going to do is we're going to define each of these parts. So this top has these three arrows, and I have a blank over here. So whenever we talk about combining like terms, each of these parts, whether it is the number by itself or a number with a variable, all of these are terms. So this top blank is terms. Make sure that you write all of these parts out and write your arrows. I have three more arrows and three more terms that we need to talk about. So this first number, that 12, that's attached to my x. Now we know what x is. What do we call x, Miss Sarles?
X is a variable.
A variable. Now remember, we've talked about variables. Variables. See, I'm not great at spelling.
It's okay.
Okay, and so 12x means that I have x, an unknown amount for right now. So I'm just giving it a variable, a symbol for its unknown value. The 12 next to it, we call that a coefficient. Talk about a hard word to spell.
That is why we do not teach spelling.
That's right. So a coefficient is a number that's attached to a variable. And Ms. Sarles, what does it mean when we have 12 next to x?
That means we have 12 being multiplied, so we would have 12 x's.
Okay, so whatever the value of x is, we'd multiply that by 12 to get our answer, so 12x. And the last part that we have here is 15. Now 15 doesn't have a variable next to it. It is just an integer, and we call those constants. Okay, so each of our parts is a term. The number that's attached to the variable is the coefficient, and the other numbers that are not attached to variables are called constants. Now that we know our parts, let's talk about what we do when we combine our terms. Okay, so here I have an example. I have 10 shapes. And if I wanted to combine my like terms, that means I need to combine my like shapes. So I'd look here, and I'd see I have some circles and I have some squares. And if we could count, how many circles do I have there?
You have 7
Okay,
circles.
so I could rewrite this. Instead of writing 7 circles, I could write 7 circles plus, and how many squares do I have?
You have 3 squares.
3 squares. And if I wanted to write that using more mathematical variables, because right now I just have shapes, could I rewrite that circle? Because that kind of looks like a 70 to me.
I know, and I would probably use a C for circle.
Ah, okay, so we're using the variable c. So 7 c's plus 3, and what do we want to use for squares?
You can use an S for square.
All right. So see, I've combined my terms. Instead of a whole bunch of circles being everywhere and a whole bunch of squares, now it's written much more precisely, and it's a lot easier to look at. Okay, so when we do it with actual mathematical terms, right here I have 6x plus 3 minus 5 plus 2x. So if I wanted to write that out in expanded form, I could write 6 x's. So I have 1, 2, 3, 4, 5, 6 x's. I have plus 3. Now those 3 are not x's, they're positives, so I have 3 positives. I have 5 negatives, so I'm going to write those 5 negatives. And I have 2 more x's. Those are positive x's, so I'm going to still go ahead and put them over here. And if I wanted to combine my like terms, I'd add up how many x's I have and what I have left of my integers. Okay, so Ms. Sarles, how many x's do I have here?
You now have 8 x's.
I have 8 x's. And when I combine out here, what am I supposed to do with these?
Well, I see that we have some 0 pairs, so we need to circle those and, so we can not count them in our final answer. So we had 3 0 pairs, and we're left with 2 negatives, so it'd be a -2 or -2.
Okay, so I've gotten from this kind of long expression down to a smaller expression, and these expressions are equivalent to each other.
Yes.
Okay, but now we don't want to draw a whole bunch of x's every time, and we don't really want to draw our 0 pairs. So what we have to do when we come across an expression is we need to look at what things can be combined. So I need to combine my terms that have variables with my other terms that have variables, and then I need to combine my constants. To help me with that, I usually put different symbols around my parts. So I have a bunch of variables. My variable here is n. So I'm just going to circle all of my variables with their coefficients. Notice that that 5 is a -5. It's 12 minus, but I'm going to count that as a negative. Okay, so I put a circle around the 3 terms that have coefficients and variables. And then the rest of these, this 12, this -5, and that 10, those are constants. So I'm going to put a different symbol. I'm not going to put a circle because then I might get confused. Or I might choose a different color even. So I'm going to go ahead and put a square. That way I don't get confused. And now I can combine my terms. So I have 2n, -5n, and 6n. How would you add those up together?
Well, I would take the 2 positives, 2n and 6n, and combine them first and get 8n.
Okay.
And then 8n minus 5n equals 3n.
Okay. So I have 3n. I'm going to go ahead and label that down here at the bottom. And then I have my constant. So I have a 12, a -5, and a 10. And how would you solve for those?
And again, I would take the 2 that are the same, so I have a +12 and a +10, and add those together, +22, and then subtract 5. That gets you a +17.
Okay. So here I have 3 positive n's, and I have 17, so this is a plus 17. So I've taken this very expanded expression that takes up a lot of room, and I've written it down into a very simple expression that is very equivalent. They're equal. And that's what combining like terms looks like. So if we wanted to go over to our whisk, I have 2 checks for understanding. So this is -6y plus 3 plus 8 minus 2y plus 10. It needs to be combined to make a simplified expression. And number 2 is 16 plus 3 minus 5q plus 16q minus 2. Combine those 2 to make them smaller, more condensed expressions, and we will talk about those tomorrow. Thank you.